Hello, myself Dr. Aditi Chatterjee from ECA department. So today I am giving a brief introduction on control system. So in a control system, it is an interconnection of components that gives the desired response. The prime objective of any control system is to maintain the output of a system at a desired value. The output variable to be regulated is termed as controlled variable. The desired value of the controlled variable is termed as reference input. A control system requires elements like sensors and final control elements like actuator to maintain the control variable at reference input. So how basic is the control system? Like filling a water tank or pressing your clothes or switching on your AC. It is done for an objective. So the desired value is very important, and for that there is also a reference input. So the main elements of a control system are control variable, reference input, control elements. These are all the basic control elements of a control system. Now for controlling the system, a sensor is a very important thing. A sensor is a device that transforms one type of physical quantity to another, like usually electrical, for example, tachometer, accelerometer, thermocouple, strain gauges, and LVDT. Sensors are used to measure the controlled variable of the system. The control system compares the desired value or desired level with the present level. If there is any difference between the reference input and the controlled variable, the controller takes the necessary action. Suppose you want to make the room temperature 24 degrees Celsius. Outside it is like 30 or 32 temperature, means normal atmospheric temperature. For that you switch on the AC. So we used to set the time. So there should be some reference with which it will be compared, and if the temperature is like the desired temperature is 24 and if the present temperature is 26, means there is a error of 2 degrees Celsius which need to be reduced, and the controller takes necessary action accordingly to reduce the temperature. We have two types of control system: open loop control system, and closed loop control system. We will also look into the differences, advantages, disadvantages in the upcoming slides. So an open loop control system is a system that operates based on predetermined set of instruction without adjusting to external factors. It's also known as a non-feedback control system. So open loop control system is basically a non-feedback control system, whereas a closed loop control system is a feedback system. There is also a feedback in the closed loop system. So in open loop control system, we have input, then we have controller, which gives control signal, and controlled process from where we get the output. The example of open loop control system could be cloth dryer. So what we do, we just set the time. There is a heating element which heats the clothes inside the machine and give actual dryness. So it will not check whether what is the status of the clothes. Means the clothes could be silk, it could be cotton clothes also. So we know that if it is silk, it will take less time for dryness, whereas if it is cotton clothes, it will take more time. So the machine is not checking whether the clothes are already dried or more time is needed, means the clothes are wet. You just set the time. It could be 5 minutes, 10 minutes. After that, the heater will stop. So it is not checking. There is no feedback. You are just setting time, and for that time the heater will run. It will remain on, and accordingly the clothes will get dried. So there is no feedback system. There is no error checking. You are just setting the timer. For example, suppose a easy example will be like walking on a road with your closed eyes. So you could not measure the direction, the path, whether there is potholes or there is disturbance in the road. You are just walking with closed eyes. So you are not checking. You are not checking in which direction you are going. So open loop system, and it's like example, it's like walking with closed eyes and in absence of any sensor. uh, and for human body we have in case of for vision we have the sensor of eyes. We are considering eyes as the sensor. Now, in closed loop control system, a system is a device that automatically regulates a system to maintain a desired state using feedback from the system. So here you can see in case of open loop system, we don't have this feedback. Feedback means what? We have a signal which comes from output towards the input. In open loop system, we have open, means there is no feedback path. It is unidirectional from input towards output. But in feedback system or in control system, we have a feedback. We have a signal which comes from output towards the input, and it checks with the reference input. Accordingly, it generates error signal. The reference input is given in the controller. The controller takes the controlling action over the plant, and there is a feedback system whether the desired output is achieved or not. So in closed loop system there is always a feedback from the output towards the input. It checks the desired reference input and accordingly it generate error signal, and the controller takes necessary action. And for example, examples of closed loop control systems are an automatic electric iron consists of a thermostat that acts as a controller of the system. A resistive heating element is present that generates heat. The sole plate of the iron instrument act as a process of the overall system. When the temperature of the sole plate attains a predefined value, then the heating action gets stopped automatically. And when the temperature falls below a certain specified value, then again heating starts inside it. So, automatic electric iron is a closed loop control system because it checks with the predefined temperature, and accordingly it takes decision. Whenever there is a decision making condition arrives, that gives you an example of closed loop control system. This is the block diagram of automatic electric iron, which is an example of closed loop control system. For example, if I give two example like for open loop and closed loop control system, like suppose you are driving a car, and the driver has been asked to maintain a speed of 80 kilometer per hour. Now it has if it is open loop system, means like you can you can like understand that if a robot drives the car, so it will press at the very beginning, it will press the accelerator and it achieves the speed of 80 kilometer. Then it does not change the pressure on the accelerator. So there will be a constant speed of 80 kilometer, but it will not sustain as there could be inclination or the road may be steep, and if it is steep, obviously there will be friction, and for that the speed will reduce, but it is not changing the pressure on the accelerator of the car. So this is a open loop system. So means it is not checking whether it is maintaining that speed of 80 kilometer per hour because of friction on the road, or because of steepness, or there may be some other disturbance like wind from the other side, which will create friction on the car, and the speed may get reduced. But the robot is not checking with it, just achieve the speed of 80 kilometer per hour at the very beginning, and after that it is maintaining that pressure on the accelerator. This is open loop system. However, if you are driving the car, or a driver is driving the car who has been asked to maintain a speed of 80 kilometer per hour, now what he will do, if there is steepness in the road, it will give more pressure on the accelerator to maintain the speed of 80 kilometer per hour. So the sensor is our eyes, who is checking the speed on the speedometer, and the brain is the controller who is taking decision, means what pressure we have to give on the paddle of the, or we have to give on the accelerator, to means it takes decision like if the speed get reduced for steepness of the road, we have to give more pressure on the accelerator. Again, when the inclination is downward in the road, we have to release the pressure on the accelerator. So the eye is the sensor, and controller is our brain who is taking decision what pressure we have to give on the accelerator, whether we have to reduce the pressure, or we have release the pressure, or we have to give more pressure on the accelerator. So this is open loops example of open loop system and closed loop system. Obviously this comes with some advantages and disadvantages. Open loop system is much simpler and less expensive, as there is no feedback system, and the components requirement is also very less, so that makes the open loop control system less expensive. Apart from that, no sensor are needed to measure the variables to provide feedback, so that also reduces the cost and simply makes the open loop system simple. In closed loop system, it can be designed to provide extreme accuracy at a steady state. Its time response can be adjusted by appropriate design. Transient response and steady state response can be controlled more conveniently and with greater flexibility. Less sensitive to system parameters variation. So these are the advantages of open loop control system and closed loop control system. Now we will move to or we will check the disadvantages. If we consider open loop control system, obviously it will have less accuracy. So the accuracy is very less in open loop system, whereas the accuracy is more in closed loop system there, because there is a continuous checking whether the desired value or the desired output is achieved or not. There is a feedback system from output towards the input. It checks with the reference input and generates error, and accordingly the controller takes decision. So that makes obviously the system more complex and more expensive. There is no, in open loop system there is no compensation for any disturbance entering into the system, since input is independent of disturbance. For example, I have given the example of driving a car by a robot. So it need to mention 80 kilometer per hour, but it is not considering the wind coming from the opposite side, or inclination or steepness of the road, or the disturbance in the road. So there is no compensation for any disturbance entering into the system. Apart from that, another disadvantage of open loop control system is its performance highly depends on the properties of the system, which sometimes may vary with respect to time. In closed loop control system, it reduces the gain of the system. And also, if the closed loop system is not properly designed, the feedback system may lead to undesirable responses. So the comparison between open loop control system and closed loop control system need to be understood and are very important for understanding the whole control system. Okay, so thank you. We will move to the next transfer function very soon. Next slide. Thank you for listening.